Hello, in this video we are going to talk about 7.2 frequency and period of simple harmonic motion. Now remember that period is the time to complete one cycle and it was equal to 2 pi over omega, and the frequency f is equal to omega over 2 pi, or from that we can say omega equals 2 pi f, or here omega is equal to 2 pi over t. Now we want to find the period or an equation for the period for a simple for an ideal spring. So we have the spring and we have a mass m over it. Remember from Hooke's law, F equals to minus kx. That's the restoring force. As we said, to have simple harmonic motion, we need to have a restoring force. Now, that force by Newton's second law is equal to m times a. So ma is going to be equal to minus kx, which means a equals minus k over m times x. We are going to write that a equal to minus omega squared x. This one will be derived in the upcoming videos where it came from minus omega squared x. So omega squared in that case, omega squared will be equal to k over m. So omega will be equal to square root of k over m. And right now we are going to take that omega and replace it for the period equation. So the period of a spring will be 2 pi over square root of k over m. Now we can rearrange this one to become period of a spring 2 pi square root of m over k. So that's the equation for the ideal spring, the period of it. Now we are going to do it for the second case, which is the simple pendulum. So we have a pendulum that's when it's at rest length L, and then when it is displaced, and we have the angle theta. So we know that using small angle approximation, sine of theta is equal to theta, and we are going to call that distance x, the displacement, and the restoring force is going to be the force of gravity. So the restoring force, that's going to be to the left. So here restoring force is the force of gravity. So F restoring, since it's going to be in the opposite direction, so it will be minus mg sine theta. We want the y component of, the x component of the force, since it's the one that to brings it back to equilibrium. So it's going to be minus mg sine theta, which we can write it as F restoring. We see that sine theta is equal to opposite over hypotenuse. So x over L, it will be equal to minus mg x over L. And by Newton's second law, we know that F naught equals to ma. So ma equals to minus mg x over L. M and m, they cancel. So a equals to minus g x over L. Again, here we are going to say a equals to minus omega squared x. So omega squared will be equal to g over L. So omega equals to square root of g over L. Again, we replace t of the pendulum in 2 pi over omega, which will be equal to 2 pi over square root g over L. So the period of the pendulum will be equal to 2 pi square root of L over G. Those are our two equations. Now for the frequency, it will be the same, just you can put it as 1 over T. If you want to find the frequency for either cases, just put it 1 over T and we can flip this equation. That's it for 7.2.